Hey class, how's it going? Hope everything's going smoothly for you. We're going to do 6.2 in this video. I sent you a introduction to the t-distribution, different video from a different professor that gives you a pretty good overview of what the t-distribution is. And then I'll focus on the how to actually do the problems. So on this first page, just some key things that you'll need is first those 2 bullet points. Like, how do you know you're using 6.2, the t-distribution? It's when you don't know the standard deviation for the population. You do know the sample standard deviation S. And then the population is normally distributed greater than or equal to 30. Other than that, you'll need this little formula. The degrees of freedom is n-1. Okay, the rest of this is some background information on the t-distribution, but we're going to get right to the problems, what you'll be doing. Excuse me. Excuse me. First thing is you're going to find the critical values. There's 2 ways we'll do that, either the t-distribution table or the StatCrunch. It's similar to when we found critical values in 6.1, but we just have to use this new distribution. Okay, so let's do this example down here. Find the critical value T sub C for a 90% confidence interval and a sample size of 15. So the C, the confidence level is 0.9, and then you're also going to need the DF, and the DF is always the sample size minus 1. So in this case, that's 15 minus 1, which is 14. And then we're going to go to the table with those numbers. Okay, so if I go to my table, let me switch that over real quick, and so we can look at that. Here it is. It's in your tables packet. You have access to that. It's the table 5, right? So we've been really using table 4, the normal distribution. This is the next one after that. Table 5 looks like this. And so really all you're doing is finding that level of confidence across the top. There's the 0.9 right there. And then just go down to the correct degrees of freedom. There it is, 14. So that's 1.761. Okay. And that's what we're going to call the TC. So that's how you do it with the table. Pretty user-friendly table, almost easier than any other way. But there's also the StatCrunch method. I can show you that real quick while we're up on the desktop. The way that works, stat, calculator, go down to the T. Right? So normally we've been going to the normal. Right now in this new section, we're going to the T. Okay, so stat calculator's T, and it looks really similar to the normal distribution. Works the same way. However, we do need to enter this DF, 14. Okay, and then confidence intervals are always between. And so make sure to click between, put the DF, and then over here is where you're going to put your percentage, 0.9. Okay, and then compute. And there's that 1.761. Ignore the negative one. The critical values, we're always just using the positive one, just like in 6.1. Okay, so that's how those work. The way the rest of this section will flow is a lot like 6.1 once we have that all figured out. So let's go back to the handout and we'll continue with finding confidence intervals now. So there it is, the TC 1.761, we've got that. Now, doing confidence intervals, you're going to find the margin of error. There's your margin of error formula. Right? Notice it looks like 6.1. It just has T instead of Z and S instead of sigma. Okay, and then you're still going to do that add and subtract thing. Okay, so let's try this example. Bottom of page 6. You randomly select 16. So there's your N. Right? The sample mean, X bar. Sample standard deviation, there's S. And then you have the C, confidence level 95%. And then assume the temperatures are normally distributed. That's good because N is only 16, so we need to have that fact. First step then, we got to find that TC. And to get the TC, again, go to your table or StatCrunch, just like we did before. Things to note, we have the degree of freedom, which is 16 minus 1, 15. And then we have the C is 0.95. So if you go to your table and just look those up, go to the 0.95 down to a 15, you'll see it says 2.131. Okay, so that's the TC. Or try it with StatCrunch. Next step, get that margin of error and that formula above up there. Right? So that's going to be TC, which is 2.131 times S, which was 10.0 or just 10, divided by square root of N, which is 16. Okay, so that's what you want to calculate. I'm just going to get out my calculator and see what that is. I'm getting about 5.3275. Okay. And then what am I doing finally to get the confidence interval? Adding it and subtracting it to the mean. So I'm doing 162 minus that. And we could just go one decimal place here. 162 plus that. Right? And for my final answer then, I'm at 156.7. And then 167.3. Okay. And the interpretation of this is we are 95% confident that the population mean temperature is between 156.7 degrees and 167.3 degrees. Okay? Cool. Now, you've had two distributions, Z and T. Just to be clear, which one do we use? Really, it just depends on the standard deviation. Don't look at anything else. So when you're reading the problem, if the standard deviation is a population, sigma, use Z. If it's the standard deviation of a sample, use T. And that is it, okay? The only other thing you have to verify is that you have one of the two things. Either the population is normally distributed or the sample size is at least 30. Okay, otherwise you can't even do a confidence interval at all. Okay, so for the rest of these, let's just decide, is it Z or T, and then do the appropriate one. Number 2, you randomly select 25 new houses, sample mean, blah, blah, blah. There it is, population standard deviation. As soon as it says that, you know it's Z. So this one is a 6.1 problem right here, just because of that fact, okay? Let's try it. So if it's a 6.1 problem, we've got to go back and think, okay, how did we do those, right? Confidence level is 95%. I need a ZC. For those, you can go back in your notes and just look at that little table. Scroll back up. Where is it? Oh my, it's so far back. There it is. I wrote all over it. This is what we did last time. Okay, 95%, that's that 1.96. Okay, back to where we were. 1.96. Gotta remember that. Okay, 1.96. Sorry if I got you dizzy on that. All right, and then find your margin of error. It's always the ZC times the standard deviation divided by square root of n. Calculate that out. That's equal to that. That's kind of bad. 10,976. There, that's what I meant to write. And then last step, what do? That one number you haven't used yet, the 181,000, add and subtract that. So I'm doing 181,000. I can just maybe do this, because these numbers are so long, I'm just gonna write it. Plus or minus, that's what that is, a plus or minus, okay? So that's the -1. There's the +1. And we're done. Okay, next, number 3. Let's just look at that standard deviation. It says sample standard deviation, so that's got to be 6.2. All right. Let's do it. So this is one where we're going to need the TC. Okay. So TC, based on 90% confidence level, and then N is 8, so DF is 7. Right? So I'm going back to my table and just look up 0.9 with 7. And I'm saying 1.895. Okay. So I'll put that there. Find your E. It's that value you just looked up times the standard deviation divided by square root of n. So 1.895 times 7.2 divided by square root 8. And that's about 4.8. Okay. Add that and subtract it from sample mean. So that's the 35.5 plus or minus 4.8. And then we'll get our final answer. So that's going to be 30.7. 40.3. All right. So those are two good examples of the difference between 6.1 and 6.2. The next thing on this last one, if it's any kind of raw data, like this one, use StatCrunch for sure. Okay. Because you're going to need the standard deviation. And so since you have to calculate that anyway, let's just do it all with StatCrunch. So I'm going to stop here on this video. In the next video, we'll focus on StatCrunch and maybe look back at these and then do this one as well. Okay, so stay tuned for the next part. That's it for now. Hope all is well, and I'll be talking to you guys again soon.